Hi, welcome to everyone. So this is Dr. Mohammad Imtiaz Hossain, I lecturer from Department of Management, Sunway Business School. So in this session, we will see the analysis of Smart PLS. So this is the conceptual framework. It's a sample for this session. So in this framework, we have the two independent variable, transformation leadership style, human resource practices, and one dependent variable, which is organizational performance, one mediating variable, which is the workforce engagement, and we have one moderator, which is decision makers' emotional competency. So this is the questionnaire based on this model, demographic, and then other variables related items. So we have to prepare this questionnaire before we conduct the analysis. In another session, I already showed that how can we run the SPSS analysis, the missing responses, how can we treat them, how can we conduct the pilot analysis by checking the reliability, how can we conduct the final analysis by checking the outliers, normality, autocorrelation, non-response bias, common method bias, demographic profile, descriptive analysis, correlation, and regression. All the analyses are already shown into the another session. So now we will see and we will run the Smart PLS analysis, structural equation modeling, SEM, PLS. So for this analysis, we need to develop two models, which is the measurement model and then structural model. In the measurement model, there are 4 steps. We have to check the indicator's reliability. Outer loading should be less than 0.7. In the step 2, we have to check the internal consistency and reliability. The convex alpha CA value should be 0.7, less than 0.7, and composite reliability also have to less than 0.7. In the step 3, we have to check the convergent validity, the AVA value, average variance extracted. This value should be 0.5. And step 4, the discriminant validity for all HTMT values should be lower than 0.90. So if we completed these 4 steps, then we already conduct the assessment for measurement model. After conducting the measurement model assessment, we have to move forward to the structural model assessment, which consists of 5 steps. The step 1, the assessment of collinearity, the BIF value should be below 5.0. The step 2, assess the path coefficient, the T value larger than the critical value, 1.98 and 2.58 considered significant with level of 5% and 1% respectively. That means the significant value should be less than 0.05. Step 3, assess the level of R square. If the R square values are less than 0.02, it's small, indicating the smalls. We can interpret if the values are 0.13, it's medium, 0.24 higher than it's called large, according to Cohen 1988. Step 4, we have to assess the effect size. The effect size F square value, if it's 0.02, is small, 0.15 indicating the medium, and 0.35 indicating the large. Step 5, assessment model, we have to check the Q square value, Q square predicted relevance should be higher than 0, higher than 0. So if more than higher than 0, that means this model have the predictive capability, predictive relevance. So if 0.02, it's indicating the small, 0.15 indicating the medium, and 0.35 indicating the large. So these are the theoretical interpretation, and then the parameter we have to check by conducting the analysis. Now we go to the hands-on. How can we run the model and how can we draw the model into the Smart PLS software? Okay, I already opened the Smart PLS interface. So in the Smart PLS interface, at first you have to create the new project for your project. So let's say organizational performance is the name of this project, organizational. of SME. We have to create. So organizational performance SME is created as a new project. Then we have to bring the data first, import the data file. So how can we import data file? We click it simply here. Then we redirect to your folder where you kept the data. So for my case, I kept in data analysis folder. So your coded data, you can bring the CSV file or Excel file, both is supported by Smart PLS. So I bring it here. The data already appeared, imported into the Smart PLS software. Here is the demographic values, and then the other independent variable, dependent variable, all other values are here. So you have to check that all the scales are matrix. So binary should be converted into the matrix. Binary should be converted into the matrix. Okay, all the matrix. Okay, it should be unchecked. The combined variables, no need. Only the independent items will be here, and demographic you can put here. So data are already ready. Then you can import. Data already imported. So here is the mean, median, and then standard deviation. The simple basic descriptive analysis already here. Correlation also can find out. These are the correlation tables. You can copy an Excel, then you can report. But our next step is we have to draw the model. How can we draw the model? Go back and then you have to create the model. You can see here is the create model. You click it, then you check which type of regression you want to turn. We click the regression, and then the PLS SEM. You click the PLS SEM, then you model name. You write down like regression performance SME. Simply, you save it. So we have to draw the model based on our conceptual framework. Since we have the first variable is independent variable is transformation leadership, TLS1, TLS2, TLS3, TLS4, you bring into the canvas. So you can see TLS already appeared here. So click here. So TLS 1, 2, 3, 4 already appeared. They have nice, beautiful boxes, flowers, and then you can move this variable also, or you can bring back these indicators into the left side. You can bring design in the bottom, you can design into the right, design the top. Okay, but normally we kept the indicators into the left side. If you have so many indicators, you can hide also. How can you hide? You click the right click, you hide the indicators. So indicators are inside. Okay, so in our case, we can hide the indicators, no issue, no worries. Then we have to bring our next variables, which is the human resource performance items. So training related items, selection related items, all the items, communication related, then performance measurement. Okay, so these items are related to human resource management practices. So all the human resource management practice related items we are bringing into the canvas. So we write name here, human resource management practice, HRMP. Click here. So many items. So we can hide the indicators. You put here. Then our mediator is workplace engagement. WE1234. We bring here is a mediator. We can hide indicators. Then our moderator is this one, decision makers. You being here, decision makers emotional competency is our moderator. We can hide. You can put it like that. Then our dependent variable is operational performance. PT1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can put here P. You can hide indicators. So then we have to connect. We have to connect. Here is the connect. Here you can see the connect option. You click it. So blue means it's ready to connect. So you connect the IV to DB first. Then IV2 to DB first. Then IV2 mediator. IV2 to mediator. Mediator to DB. Then moderator. You can connect to the IV1 to DB relationship. Then IV2 to DB relationship. So based on your model, you design and you connect the relationship. So if you wanted to move, also can move by clicking the select. Okay, when you select, that means you can select the variables and you can move it here. Okay, so our models are ready already. Our models are ready. So two independent variable, one mediator, one moderator, and one dependent variable. Simple model. Then we have to run the analysis. How can we run the analysis? We have to. So if you remember, I already explained that we have to develop two models, the measurement model and structural model. So this is the measurement model. So measurement model, we have to run the here analysis here, calculate your PLS algorithm, PLS SM algorithm. You click place algorithm. So path, standardized and default. You click start calculation. If your scales have 5 Likert scale, okay, if your all the variables are consistent, the 5 Likert scale, then you can standardize. But if your variables have mixed scales, like 5 Likert scale for one variable, 7 Likert scale for another variable, 9 Likert scale for another variable, 3 Likert scale for another variable, if it mixed, then you can check the unstandardized. Since we using the 5 Likert scale for all the variables, then we check the standardized. Then start calculation. So calculation already done. So this is the report. You see the values already appearing here. So this is the graphical representation of the model, structural model. So you can copy, you can click the right side of the cursor, then export as image. So if you copy that, it will show that which format you want, PNG or SVG. Normally we download the PNG format. Then you check the external file, then you export, and you can save to the data analysis. Okay, it's the PLS4.0 model. So save it. So your model already saved in the folder. So you have to report that the model. Then you have to report the path coefficient. You have to report the construct reliability and validity. So you can see the result here. The convex alpha value. The convex alpha value should be higher than 0.7. So it's green since the convex alpha higher than 0.7. Composite reliability CR value also have to be higher than 0.7. This composite reliability also higher than 0.7. AVA value should be 0.50. Okay, higher than 0.50. If any problem exists into the data, then it should be red. So you have to go to the data and then we have to rectify the issue and the reanalysis again. Okay. So that is another procedure, but we have to report this construct reliability and validity. You can copy Excel, Word, and then paste into the Word file. Then also have to report the F-square value. Okay. F-square value, I already showed the interpretation earlier, which means what. Then R-square value, we also have to report. Make sure you report the R-square adjusted one. Okay. If less than 0.02, then it's poor or lower. If higher than 0.50 or 40, then it's moderate. Higher than 0.7, that is significant or strong R-square value here. Then we have to check the discriminant validity, the STMT. STMT value should have the less than 0.90, should be less than 0.90. So since some values are higher than 0.90, that means they have got problem or issues into the data set. So we have to go to the outer loading, then we have to check that which items got problem. If any items got problem, less than 0.70, then we have to delete the item, like TRN got problem. So we have to delete that. So there are some other procedures to rectify that, but that is another issue. But right now, what is our main concern? We have to report the STMT matrix. We have to report for our discriminant validity. So at first, I'm repeating again, we have to report the construct reliability validity, CA value, CR value, and AVA value. And then we have to report the STMT value for the discriminant validity. So, and then R square and F square, R square and F square values we have to report. The BIF value, collinearity also have to report. The BIF value should be less than 5.0. So since our values are less than 5.0, so it's green. Okay, it's green. That means they have no collinearity issue. No collinearity issue. Then we have to, don't forget to save this. Okay, if you didn't save, then you cannot regain again. So make sure you save it, so you can get back whenever you reuse again. So graphical outcome, also you have to download image, report, and those are the tables just now I show you. Also have to report. You can bring this result in Excel file also. Here is the Excel file. You can click it and it will be downloaded in Excel sheet. So from there also you can copy the tables and then report into the Word file. So it's two-way. You can right click, copy, or click here, or you can bring the whole Excel file, which is easier. Then we go back. So our PLS measurement model is already done. Now we go for the structural model. So this model will be keep same. Then for structural model analysis, you have to click here. Then you have to do the bootstrapping for the second step, for the second model. Bootstrapping, you click the resamples 5000, whatever have, just keep it in this way. Two tails, fix it, then start calculation. Start calculation, you can see that calculation is happening, percentage. So calculation already done. So another model provided by the software, beautiful model. So you copy, click, right click, and export as image. So this model also you have to report. So this is the structural model. Previous one was the measurement model. So this is structural model, you have to report that. So by this analysis, we can see our hypothesis are supported or not supported, which is our main concern. So you can go for the path coefficient. You can see the hypotheses are there, relationships. You can copy this table and you can find out the p-values at the end. So if the p-values are less than 0.05, that means the hypotheses are supported. If higher than 0.05, the hypotheses are not supported. So you have to report in this way. And then we can report by the t-statistic also. If the results are higher than 1.6468, then we can report that it's also significant. So, but normally we report by the p-values. Okay, the p-value should be less than 0.05 for the significant level. So you can find out the direct relationship, IV and DV relationship, and moderating relationship in this format. But for the mediation relationship, you have to go to the indirect effect. Specific indirect effect for the mediation. So you have to copy this table also for the mediating result. So the TLS mediating by the WE by OP, HRMP, the second IV mediating by WE to the dependent variable, which is OP. So since the p-values are higher than 0.05, that means we don't have any significant mediating relationship in this model. So don't forget to save it again. So there will be two models, have to save the measurement model and structural model, and we have to report the two figures also, measurement model figures and structural figures. For the Q-square predict, so that's the two models here we have to report. And then for the Q-square predict, we can find out in this analysis. You can see, you go back and then you click the analysis and then we go to the PLS predict. So PLS predict, you click 10, whatever have, you check it out and then start calculation. So calculation is done. So you go to the PLS predict LV summary. So you can see Q-square predict result is here, 0.72 and 0.78. So you have to report that. The interpretation I already explained previously. That means the model's predictive is quite higher, is indicating. So this figure, no need to report, just the previous two figures have to report are quite fine. So that's how we conducted the SEMPLS structural model and then measurement model analysis. So I hope you get the brief idea about the PLS analysis. Thank you. Okay, now I'm showing that how can you report to the structural equation modeling result. So assessment of structural equation modeling. You just have to write down some basic information about the SEMPLS, what is the purpose of SEMPLS, in what condition we can use the SEMPLS. So for the SEMPLS, I already explained that we have to develop two models, and how can we do the models we already showed in the hands-on. The measurement model, at first we have to create. So in the measurement model, we have to check first the constant validity and reliability. And the constant validity and reliability, these are the table we have to report, and then convergent validity also have to be taken. And this is the table I'm talking about, the internal consistency and convergent validity result. So at first we have to report the variables, then the short coding is optional, the factor loading, then factor loading or outer loading also can be said, and convex alpha result should be more than 0.7, convergent reliability should be more than 0.7, and AVE value should be more than 0.5. So this is the parameter. You have to report that. How can you get this result? I already shown in the videos that from the PLS outcome, you can copy paste the tables, or you can export from the Excel option in the Excel file. And these are the figure 1 we have to report, which is the measurement model. Okay. Presentation of measurement model. Then we have to report the discriminant validity. Discriminant validity, we have Fournette-Likert criterion, or STMT. Mostly now STMT is suggested to report. Fournette-Likert is outdated already. So STMT report you can get from the Excel, or copy paste the result from the Smart PLS, and then you report that there should not be more than 0.90. And cross-loading or outer loading you can report from the Smart PLS result. Then second model is the structural model, where we can get our hypothesis result and the quality of the model. So at first we have to check the R square. The R square values should be reported here. The R square values can be found from the bootstrapping result, which we already explained. This is the parameter you can put into the node. Then effect size F square. F square is also you have to report. You can get from the Smart PLS result. This is the parameter of the F square according to the Cohen. And BIF, inner BIF, multicollinearity issues can be treated by BIF. So BIF should be less than 5.0, or some scholars suggested 3.3 also can be considered as a parameter or cutoff value. So BIF should be result like this way, copy and paste, or you can download from the Excel. Then Q square value or predictive relevance, I have to report that. So Q square values are reporting in this way. So Q square predict should be more than 0. So if more than 0, that means this model have the predictive capacity. RMSE and MAE is optional. You can report it or you can skip it. Then path coefficient result, which is hypothesis accepted or rejected options. So this result, you can at first you can show the direct relationship, independent variable and dependent variable result. So these are the path hypothesis. First independent variable and then dependent variable. So which is significant because p values are less than 0.05. So significant. And then the second independent variable and dependent variable, then mediator and then dependent variable. So that's how we can direct relationship. We have to report first. Here is the cutoff value. P value should be less than 0.05. Then indirect relationship, the mediating relationship and moderation relationship, you can report separately in another table. So this at first we report the mediation. So the independent variable, first independent variable, mediator, and dependent variable. We have to check the p values. Since it's higher than 0.05, that means not significant. And the second hypothesis of the mediation is significant because it's less than 0.05. Moderation also same. Similar way, you can report the moderator, independent variable, and the mediator or dependent variable. It depends on your how you design your model. So not significant because higher than 0.05, not significant because it's higher than 0.05. So that's how we report our mediation moderation. And then we have to report the figure also. This is a structural model figure from the bootstrapping result. So you just copy and paste here. Mediation analysis also can be shown separately, but we already explained. So that's all for the things. And then at the end, you can report the hypothesis summary in a nice table. All the hypotheses here, and then hypothesis explained here, and then the result, which is accepted or rejected. You can report in this way. So it can give a clear picture of your result. Then in this chapter also you can explain or interpret, or next chapter also you can explain the result. That's all for the interpretation of SMPLS result.